This is problem number 1 from section 3.2. In this problem they ask us to solve the following equation, and you'll notice that we have a quadratic equation. There are actually 4 methods to solving quadratics. You're going to see me post this a lot and talk about the different methods of solving quadratics throughout this section and throughout this chapter. The 4 ways: number 1, factoring; number 2, completing the square; number 3, quadratic equation; number 4, using square roots. We're going to really try to solve as many quadratic equations as we can using either factoring or just taking the square root. Those two are the easiest concepts to solve quadratics with, and then if we can't do those two, either 1 or 4, then we'll use either completing the square or the quadratic equation to solve. Now, how do you determine which method to use? Well, first of all, we should probably start with square roots. I kind of have these out of order, but we should probably start by trying to solve it using square roots. When you look and you see that there is an x squared and then there's another term that has an x in it, that takes the square root method out. The only way that we can actually solve using square roots is if this said x squared plus 2 equals 0. Then we could actually use the square root method, because we could just, if we ignored the 3x term, we could subtract the 2 over and then square root the problem to get our solutions. Because the 3x is there, the next step we're going to try is factoring. So what I do is I look at the last term and I figure out what are the factors of 2. Well, the factors of 2 are 2 and 1. And then I ask myself, if I have the factors 2 and 1, do the factors 2 and 1 add to the middle, which is 3. Well, 2 plus 1 is 3. So this equation is factorable. So I'm going to go ahead and use factoring to solve this. So I usually write my ending term out here, and then I would write its factors underneath, 2 and 1, and then I would look at, okay, does 2 and 1 add to 3? Yes. So then that means that this splits into 2 binomials. The x squared splits to x and x, and I have 2 and 1, and I need it to be a positive 2 at the end when they multiply and a positive 3 in the middle, so that means I'm going to add 2 and I'm going to add 1. Now, just to check this to make sure that we actually factored it correctly, you can always, out to the side, and I'll do that here, you can always multiply that back out. So I'd take x times x, which is x squared, x times 1, which is just 1x, 2 times x, which is 2x, and 2 times 1, which is 2. And you'll see that when you add the middles together, you get x squared plus 3x plus 2. So this binomial times this binomial, the factored form of this equation, is the exact same as this the equation above it. At this point, we can use what's called the zero product property. The zero product property says that if we have 2 things being multiplied, right? We have a binomial times a binomial. If 2 things are being multiplied and they equal 0, right? So the product is 0. Then one of these 2 things must have been 0, because you can only multiply by 0 to get 0. So we're going to set this x plus 2 equal to 0, or x plus 1 is equal to 0. And this is called the zero product property. At this point, then, we can solve each of these to find our 2 possible solutions. So we subtract 2 from each side, x equal negative 2, or subtract 1 from each side, x equal negative 1. So the solutions to this problem is x equal negative 2 or x equal negative 1. And how do we solve that? We used factoring to do it.